So, how many engineers does it take to maintain 11 API clients? Hello, everyone. I'm Thomas Raffray. I'm a team lead at Algolia, and I'm in charge of our API clients. Before that, I oversaw the automation and development of various parts of several of our API clients. Recently, I've assembled a new team focused on improving and maintaining our automation pipeline. We will get to that in a moment. Today, I would like to take you on a journey through the history of API clients at Algolia and explain how we manage to maintain 11 API clients. So, how many engineers does it take to maintain 11 API clients? 11 engineers. Thank you for coming to my TED Talk. Any questions? No, I'm kidding. The answer is more complex because it's the question that's actually more complex. Even though it's a solution we have considered, as we will see later, but let's start with the beginning. If you are here tonight, and if you are a developer using Algolia, there is a good chance you have used one of our API clients. How is that possible? First off, we support 11 languages. Yay, that's amazing. Some are JVM-based, like Java, Kotlin, Dart, and Scala. Some are scripting languages, TypeScript, Python, Ruby, PHP, and we even support compile languages like Swift, Go, and C#. But we also support frameworks. Woohoo, even better. Rails for Ruby, Django for Python, Laravel and Symfony for PHP. On the downside, each one of these comes with its own bugs and maintenance requirements. Great upside though, you can target all the products that make the Algolia platform. Because if Algolia is first and foremost a search API that can be customized for your data, it goes way beyond search today. Today, Algolia also offers other satellite products like neural search, recommendation, analytic events, etc. But everything stays as easily accessible because Algolia is API first, meaning we try to cover as many developers as possible, and therefore, as we saw just before, as many languages as possible. Except it makes for a devastating formula. 11 languages times 10 APIs plus 4 frameworks, it's over 100 packages to maintain. And here, when I say to maintain, it means over 100 packages to build, to keep consistent, and over 100 packages with bugs to fix. So we try to find a solution. Solution 1, a dedicated team per language, meaning we focus on covering all languages. There are trade-offs. First, cognitive complexity. Every developer must be familiar with all APIs. That's very difficult. Idle devs. When there is no feature on the API side, the dev would be jobless. And as we all know, people are expensive. We don't want to have ghost coders. It's a bad thing. So we needed to try something else. What about embedded engineers? We shift the focus on covering all APIs, and we ask each API team to update the clients directly. But there are downsides too. First, cognitive complexity. The devs would be focused on the actual API features, not on the clients, which could lead to bugs due to context switching. Also, we would be facing the jack of all trades problem. All the devs would be expert on no language, so they wouldn't know the specificities. And who would be responsible for cross-functional changes, like Algolia's retry strategy, for example? We need a third solution, something that helps us handle all our API clients. If only there was a standard, a technology that could take a description of an API from one hand, and on the other hand, transform them into some code that could call these APIs. Enters OpenAPI, the most widely used API description standard in the world. The OpenAPI specification explains how to write machine-readable YAML or JSON blueprints for describing RESTful APIs, covering endpoints, parameters, authentication, schemas, responses, everything we need. And this in order to automate client code generation, validation, testing, and even documentation. Remember this word because we built exactly this, and it's amazing. But let me show you. We started with a CLI. Our CLI allows us to streamline all our processes in a centralized tool. It's based on Docker, so it's a universal dev environment. It validates, links, and formats the specification for each API to make sure they match the OpenAPI defined standard. It compiles our custom code generators that are built on top of the OpenAPI provided ones. And finally, it generates client code from Mustache files. They are templates that provide variable insertion, basic loops, and conditions. Let's dive into the details of this pipeline. In a code generation pipeline, the first step is to have a good baseline, the specification. Those blueprints describe our APIs from A to Z. There has been a lot of introspection work to manually write Algolia's 12 APIs because we wanted to write one spec per API. We followed as closely as possible the OpenAPI standard, which made the work easier, even if it was time-consuming. Then you need generators. OpenAPI provides some base generators that can give you client code from your specs, but they will be very generics. They are written so you can extend them with your own specificities and preferences, and that's what we did. We also customized the Mustache templates that act like a second custom overlay to handle language-specific features like casing, custom parameters, etc. Ultimately, now we write code that writes code. Finally, you get some generated client code. Our classes are commented, our methods are faithful to what our APIs expect. For each API evolution, we have an automatic code regeneration. If we find a bug, it's instantly fixed in all 11 languages, and that's a convenience that you don't want to lose. To sum up, it's a single source of truth for everything. And this code is the final code that will be published. Well, almost. Because usually your IDE will even white spaces automatically, and advanced LSPs will standardize your code style. Like, for example, it will remove useless returns in Swift. So you don't have to think about it. But with generated code, this is a step that must be done manually. Without formatting, it would be very difficult to compare the changes between two generations and to append them to the change logs. Okay, we need to be rational. Even if we have managed to generate a large part of our code, there is still some code that we need to write manually. We can think of it as an usual 80-20 split. 80% of the code is generated automatically from the specification. That means that about 20% is still written manually because it is specific to either Algolia or to the language. For example, each language has its own specific features. In Python, we need to generate two different clients, one that's synchronous and one that's asynchronous. So that means manual code. Some languages accept generic types like JavaScript or Java, so we can return records from your Algolia indices that matches exactly the types that you are waiting for. On the Algolia specificities side, there is, for example, the retry strategy. It's a system that automatically retry failing requests based on their error codes with an exponential payment. To recap, we built this CLI in the center based on OpenAPI tools, specs, and generators, and it gives us code on the other side. It's a more pleasant formula than 11 times 10 plus 4 or whatever it was. Generated code is good. You know what's better? Tested code, of course. So let's take back our pipeline, since it works well. We'll use the same model and generate the test. We wrote specifications in JSON. We wrote specific generators for the test in Java. And now, in addition to generating code, we generate tests. We wrote code that writes tests, because ultimately, tests are code too. And knowing that our generated code is tested is also a comfort we can no longer do without. Indeed, our CLI allows us to launch in parallel all our test suites for all languages and APIs. So it validates that our clients are reliable for all those APIs in all those languages. Nice. Our code is generated. Now it's tested. What could be even better? Tested code that's available to our users, to you. Remember this pipeline? Let's use the same model again and just add a third step at the end. But this release step, it's not just about making the code available. It's also about making it understandable. Before releasing a new version, we will also generate the documentation for our clients. It auto-updates when anything changes on the API side, and it even generates code samples, little snippets of code that we can embed everywhere, like in our documentation, or even in our dashboard if we want to, like if we want to help our users use any of our features from there. And then, finally, we release each of the language on their own dedicated package manager platform. And even for multiple builds, like Kotlin and Swift for macOS and Linux. Just so you know, the entire pipeline that I just showed you, it takes only a little more time than my talk to run from the beginning to the end. All right, let's take a deep breath here. That was a lot to unpack. So, to answer the question from the beginning, how many engineers does it take to maintain 11 API clients? The answer is 3 engineers. With a catch. 3 engineers to maintain this pipeline. But that's not counting the developers who built it and the amazing open source communities that wrote the tools needed to build it. Because if you want to take away 2 points from this talk, I'd say first, there is no point in rewriting everything. There are incredible open source projects out there, thanks to standards that we can rely on. And if you are looking to automate, there is no point in trying to automate everything. You have to assume that there will always be some part that needs humans, at least for now. Oh, and one last thing. Everything is open source. Anyone can contribute. You can go on GitHub and check out the repo if you want to take a look, or adapt it and use it for your own pipeline, for your own needs. Thank you very much for joining us tonight. Please don't hesitate if you have any question.
Thank you, Thomas. Very much appreciate the run through here. I have a couple questions myself. First of all, I would imagine that one of the kind of the nice sort of added effects of this is feature completeness, right? I know when I first joined Algolia and we had handwritten SDKs, the challenge would be a new feature would launch and maybe you'd have it in JavaScript, but not in Go or what have you. I would imagine that this allows a feature to be launched across all 11 simultaneously.
Yeah, exactly. And you just have to write some YAML or JSON in the specification, and like almost instantly in a few minutes, the API clients would be updated, and you would be able to target those new endpoints.
Very cool. And so, out of my personal curiosity, if I was elsewhere where we didn't have generated SDKs, I know we built sort of a custom pipeline on top of some open source components. Obviously, we could go grab what Algolia has done, but were there any off the shelf products that you looked at that did something similar?
Like similar libraries that does this kind of pipeline
For like,
automation.
yeah, for SDK generation, like, was there anything you kind of looked at that was, sort of pre-baked?
Yeah, actually, there are multiple libraries that exist that does this kind of client code generation. And we choose to go with OpenAPI because it's the most widely used one. So if you have a question, there is a big community behind it, so you can just go to the forums, and a lot of the time, if you have a question, it will already be asked and answered.
Yeah. So building on the shoulders of giants, but
Yeah.
still with the flexibility of being able to do our own thing.
Yeah, exactly.
Okay. Well, I've been selfishly asking all the questions. I've got a couple from our Q&A. The first one's from Tim. Are tests only unit tests, or do they hit the real Algolia APIs?
Indeed, we have both. We have unit tests, like I think we are almost at 1,000 unit tests, and we also have a lot of end-to-end tests that really target indices at Algolia to be sure that we cover everything and it really works.
And from Paul, who we saw earlier, Paul wants to know, does an automated system like this help allow other teams generate their own client specs?
Yeah, exactly. That's a goal we have in the near future. We want to help internal teams on board on our pipeline, so they can generate even a small private client, like when they are launching new features, so they can test them out more easily, and then they would just have to update the specs, and the public client would be available to everyone.
Very cool. Very cool. All right, pop quiz. How many of the 11 clients can you name?
Oh, all 11 of them.
Let's see.
Okay, you mean the languages?
Yeah, exactly.
Yeah. Okay, so Java, Scala, Dart, Kotlin, TypeScript, Ruby, PHP, Go, C#, Swift. That's 11, right?
I think I counted 10, but I can't remember.
My God, maybe.
We got close.
Did I forgot like JavaScript or something, or one of the most obvious one? Python, maybe?
Python. I think Python was the one we didn't say. That's the one. There, that gets us to 11. Awesome. Well, you win our quiz show. Your prize is my thanks, and I'll mail you one of these snowflakes afterwards. How about that?
Nice. Perfect. Thank you.
All right. Well, thank you so much, Thomas. Appreciate the time.